Here we have a block that is being pulled across a rough surface with a force of Ft, force of tension. It's being pulled by a rope. And this block is accelerating to the right. So my question is, what is the force of friction? Now, this is easy, or may seem easier if you have letters, if you have numbers instead of letters, but we're just going to go with what we've been given as variables instead of numbers, because that's typically the way that you'll see these questions asked. All right, so let's say that this theta, this angle is phi instead of theta. Let's just call it phi. All right, so what is the force of friction? First things first, the first thing you have to do, obviously, every single time is draw a free body diagram. I'm going to draw mine off to the side. Sometimes you'll see it'll ask you to draw the forces, not the components, meaning that this force of tension is going to be pulled at an angle. You're not going to draw the force of tension in the x direction and the force of tension in the y direction. All right, so if this block is accelerating to the right, that means the right force is going to be bigger than the left force. So I'm going to make this a little smaller. This is going to be my force of friction. That's what we're going to be looking for. And then the normal force, which is going to be smaller than the force of gravity because this is being pulled up. All right, so we've drawn a picture, we've drawn our free body diagram. The next step is just to sum the forces. So I'm going to sum the forces in the x direction. So that gives me the force of tension in the x direction. I'll draw that in real quick right here. We get this, that black dotted line, that's going to be the force of tension in the x direction. And then we'll have, we'll dot in this blue up here. This is the force of tension in the y direction. Okay, so force of tension in the x, force of tension in the y. So when I look at this, the force of tension in the x direction is going to be positive because I'm going to call the direction that it's accelerating in positive, and then the force of friction will be negative. The sum of the forces in this case, because this object is accelerating, is not going to be 0. That's going to be the mass of the block times its acceleration. Okay, so how do you find this ftx? If this angle is phi, then the force of tension in the x direction, this is the adjacent side. So if I take the cosine of theta, that is the adjacent force of tension in the x direction, over my hypotenuse, the force of tension, meaning that the force of tension in the x direction is just going to be ft cosine theta. Okay, so then I can just plug that in right here for the force of tension in the x direction, ft cosine theta minus the force of friction, and then I can move this to the other side. So mass times acceleration equals minus the force of tension times this cosine of theta equals negative force of friction, and we'll just this and this and this. So this looks a little bit funky, so I'm just going to rearrange and say that the force of friction is the force of tension times the cosine of, phi, force of tension times the cosine of phi minus the mass of the object times its acceleration. Now this question could have just as easily asked, what is the acceleration? And so if that was the case, we can come back to this equation and then just divide both sides by the mass. So I'm just going to rewrite that equation. Mass times acceleration is the force of tension times the cosine of phi minus the force of friction. Divide everything by m, and so the acceleration will be the force of tension times the cosine of phi minus the force of friction all over the mass. That can be written like this, or maybe you want to write it like this, depending on what you think. So you can easily find the acceleration or the mass or the force of friction once you have written your sum of the forces equation.